My apologies, the custodian came in. But back to what I was saying. Would a mutation in a sperm cell be passed on to the offspring? Why or why not? Well, all you have to do is think about the fact that what is being used in reproduction? What is being used to create babies? If sperm is being used to create babies, then yes. Because sperm or eggs is used in reproduction. So now I want you guys to go and think on your own. Would a mutation in a skin cell be passed on to offspring? Are they used in reproduction? So you'll answer that one on your own. Another thing that you should hopefully be able to fill out on your own is this chart of going from DNA to DNA, which is also known as DNA replication, and going from DNA to RNA transcription, and then of course how to use your codon chart. If you don't know how to do that, you need to speak to me immediately because, yeah. So I'm gonna go ahead and move on to the practice part. Cool. So first thing that you have to do for all of these problems is count every 3 bases and draw a vertical line. If you don't do this, your paper will not be graded. It also will make it much more difficult for you to see the actual mutations. So again, you're just counting every 3 bases and drawing a vertical line. Cool. Done that for all of them. And so now what I'm going to do is I'm going to compare every 3 bases. So to my original. Okay, this is my original. And I have all these mutants down here. I'm comparing each mutant to the original. And I'll compare mutant 2 to the original. I'll compare mutant 3 to the original. Okay, and I'm just trying to see where the mutations are. So the first thing that I want to do is look at the first 3 bases. So we have TAC, TAC. Is that identical? Yes, there's no mutation. How about here? GCG, GCG. Is there a difference there? No, no mutation is found. TGC, TGC, any mutation? No, those are identical as well. ACG, ACG, are those identical? Yep, still haven't found a mutation. Let's keep going. ATG, ATC. Ah, there is our mutation. So like the directions say, we're going to circle our mutation. Cool. Now I'm going to do the same exact thing for all of these. Just kidding. Y'all are going to do that on your own. So what you would do is I'm not going to fill out all of this because you can do that on your own. I'm just going to fill out this one. I've identified my mutation just to demonstrate how you're supposed to go about this. So let's do our original mRNA sequence. A with U, T with A, G with C. Now look at my codon chart. I'm finding UAC, U, A, C. So now I'm TYR. Oh my God. So no, that's the amino acid tyrosine. Okay, now I'm gonna do my mutation one and see what happens. So I have ATC, so UAG. Let's see what UAG is. UAG. That's a stop codon. So when it comes to the type of mutation, I originally had a TYR, then I had a stop. So that means, what type of mutation is that? This one right here. Because it made a stop codon. It went from one amino acid to a stop codon. That tells me that it is a nonsense mutation. Cool. Now I'm going to do the same thing for mutation 2. I'm going to compare, hold on, where's my highlighter? I'm going to compare this to this. Is there a difference? No. This to this, is there a difference? No. This to this, is there a difference? No. And I'm going to keep going until I identify where my mutation is. Then, looking at the amino acid compared to the original, I'll be able to determine which of my mutations it is. Okay, cool. So that's pretty much how you're going to do this entire worksheet. You're making your mRNA, then your amino acid using your codon chart. And then from there, you're able to figure out what exactly the mutation is.